Hi friends, today we're going to talk about solving systems of equations by elimination. You can see the steps up here. Write both equations in standard form. That just means that x and y are on the same side. We want to make it so either x or y has opposite numbers in front of it. So let's say if we had 3x in one equation, we would want a negative 3x in the other equation. If that isn't already happening, then we have to decide which variable we want to eliminate between the x and the y, and then multiply one or both of the equations so we have opposite numbers in front of it. You'll see in some of the examples how we do that. Add the equations together. So really it's just like combine like terms. After step 3, you're only going to have one variable, either x or y. You'll solve for that variable and then plug it back in to solve for the other variable like we did when we were doing solving by substitution. So let's look here. If I look, I see that we have positive 4y and negative 4y. So we already have opposite numbers in front of my y's, which means my y's are going to be eliminated. So really just think about this as combining like terms. So like negative x plus negative 3x is going to give us negative 4x. The y's go away. They get eliminated, which is what we wanted to happen. And then if we look at our constants, our numbers that don't have an x in front of them or a y in front of them, negative 7 plus 27 is 20. So now again, after my elimination step, I only have one variable. I just have my x. So I'll solve for that by dividing both sides by negative 4, and we'll get x equals negative 5. To find y then, you can plug it into either one of the equations, whichever equation looks easier for you to deal with, it doesn't matter. I'm going to plug it into this first equation. Negative x, so negative 5 plus 4y is negative 7. Negative 5 is 5 plus 4y is negative 7. We'll take 5 from both sides. We get 4y is negative 12. And then dividing both sides by 4, we get y is negative 3. Don't forget to write your final answer as a point. Negative 5, comma negative 3. You can always check your answer if you wanted to. Plug negative 5 in for x on both equations and negative 3 in for y on both equations, and make sure that the numbers fit. Let's look at another one. Here I see I already have opposite numbers in front of my x's, which means I'm going to end up eliminating my x's. Then I have negative y and negative 2y, and then negative 9 and negative 9. So I can go ahead right away and just combine my like terms. Negative 3x plus 3x, those are going to go away. Negative y plus negative 2y is negative 3y. And negative 9 plus negative 9 is negative 18. Dividing both sides by negative 3, we'll get that y is positive 6. And again, you can plug it into either equation to find x. I'm going to plug it into my first one. So negative 3x minus 6, because that's what y is 6, equals negative 9. Adding 6 to both sides, I'll get negative 3x equals negative 3. And then dividing by negative 3, I'll get x is positive 1. So our final answer is 1, 6. Make sure you write the final answer as a point. Don't just leave it as x equals y equals. All right, let's look here. I notice that I don't have opposite numbers in front of either my x's or my y's. I have 21x minus 15y, 7x minus 5y. So now we need to decide which one of these do we want to eliminate. I either have to eliminate the x or the y. Sometimes it's easier to eliminate one over the other. In this case, it really doesn't matter. So I'm going to choose to eliminate my x. Just going to make a note to myself. That means I need to get opposite numbers in front of my x. I know I have 21x in the first equation, which means in my second equation, I need to get to negative 21x. The only way to do that is by multiplying everything by a negative 3. Both sides. Again, the reason I want to do that is because now that equation, after I multiply through here, negative 21x, negative 3 times negative 5 is positive 15y, equals positive 9. And then I'm just going to rewrite my original equation, my first equation there, 21x minus 15y is negative 9. So again, this equation, I multiplied everything by negative 3 to get what I have written in green. And then this equation, I just rewrote it there. So my x's and my y's are lined up. Now I can combine like terms. Here, negative 21x plus 21x, those just go away. I get 0 or they just cancel. If I look at my positive 15y minus 15y, well, those also go away. And then over here, my positive 9 and negative 9 also go away. So technically, I guess I would have 0 plus 0 equals 0. Everything went away. If every single thing goes away and you're left with a true statement, like here I'd be left with 0 equals 0, then my answer is infinitely many solutions. You can either draw the infinity sign, infinite solutions, or you can write it, infinite solutions. If for some reason the x's and the y's both went away and you were left with an untrue statement, like let's say here I was left with 0 equals 4, then it would be no solutions. But in this case, those are actually the exact same line. All right, let's look at another one. Here, again, we don't have opposite numbers in front of our x or our y, so we need to decide which one we want to eliminate. I'm going to say eliminate the x because we already have a positive x and a negative x. So now I have a negative 7x in my first equation and a positive 6x in my second equation. To make those be the same number in front of them, I'm going to multiply everything in my first equation by 6 and everything in my second equation by 7. Because this is a 7, that's why I'm multiplying by 7. This is a 6, that's why I'm multiplying by 6. So my first equation then becomes 6 times negative 7 is negative 42x minus 6 times 2 is 12y equals 4 times 6 is 24. And then my second equation, 7 times 6x is 42x minus 7 times 7 is 49y equals 14 times 7 is 98. So again, let me go back to when I multiplied by 6 and 7. The reason I did that is because now I have 42 and negative 42 in front of my x's. So I'm going to go ahead and combine like terms here. Negative 42x plus 42x, those go away. Negative 12y and negative 49y is negative 61y. 24 and 98 is 122. Dividing both sides by negative 61. I'll get that y is negative 2. Now to find x, you can really plug it in to any of these 4 equations. So either your original equation or your new equations. To me, this equation right here looks easiest just because there's less negatives. So 6x minus 7 times negative 2, because that's what y is, equals 14. So again, y is negative 2. That's why I plugged that in there. Simplifying then, 6x plus 14 equals 14. Taking 14 from both sides, we get 6x is 0, which means x is 0. So our final answer then, 0, comma, negative 2. All right, let's look at 2 more where we're going to have to multiply both of them. If we look here, again, I don't have opposite numbers in front of my x's. I have a 4 and a 7 in front of the x, negative 3 and positive 2 in front of my y. I'm going to choose to eliminate my y, only because for my y's, one of them is already positive and one of them is already negative. I have a negative 3y in my first equation, positive 2y in my second equation, which means I'm going to multiply my first equation by a positive 2 on both sides and multiply my second equation by a negative 3 on both sides. So my first equation then, 2 times 4x is 8x. Take away 2 times 3y is 6y. Equals 2 times 9 is 18. My second equation then, negative 3 times 7x is negative 21x. Negative 3, oops, I'm sorry. We didn't want to multiply by negative 3. We just wanted to multiply by regular 3. If I did a negative 3, it would not give me opposite numbers. So we're multiplying by a positive 3 here. So 3 times 7x is 21x. 3 times 2y is 6y. And 3 times negative 6 is negative 18. So 8x and 21x is 29x. The y's go away. 18 and negative 18 is 0. So finishing this off, we will get x equals 0. Now to find y, again, I can choose any of my 4 equations, either of my 2 original equations or my 2 new equations. I'm going to do this equation only because it's positive 7x and positive 2y. So instead of 7x, I'm going to say 7 times 0 because that's what x is. Plus 2y is negative 6. So 0 plus 2y is negative 6. Dividing both sides by 2, I'll get y is negative 3. So my final answer, 0, negative 3. All right, one more. Here I'm going to choose to eliminate my y because they already have opposite signs. I have a negative y in my first equation, a positive y in my second equation. So I'm going to multiply my whole first equation by 3 because that's what's in front of y on my second equation. And then I'm going to multiply my whole second equation by 4. And that's how we know that we're going to get opposite numbers in front of our y's. So my first equation, instead of 3x minus 4y, I get 9x minus 12y equals negative 27, because I'm multiplying both sides by 3. My second equation, 4 times 5x is 20x, plus 4 times 3y is 12y, equals 14 times 4 is 56. Now I have opposite numbers in front of my y's, which is what I wanted. So when I combine like terms here, 9x and 20x is 29x. The y's go away. Negative 27 and 56 is 29. Dividing both sides by 29, I'll get x is 1. Now to find y, I'm going to use this equation before it's multiplied by 4. So 5x is 5 times 1, plus 3y is 14. 5 plus 3y is 14. Take 5 from both sides. 3y is 9. And dividing by 3, we'll get y equals 3. So our final answer then is 1, 3. All right, friends, have a nice day.